All right, look at the title for lesson 27. What does it say? More what?
Geometric proofs.
Which, again, do I expect you to have this all figured out at this point? No, I really don't. I don't know how you could at this point, all right? We haven't done that much practice. We've had one lesson on it. But I want you to start seeing some trends and things that will help you. I always laugh when people go, I don't know what to put down. You can always put your given down for your first step, and you can always say your last step is your what? Proof. You got 3 points on your proof right there, right? Like, you know, but here's the thing. What you're given should tell you information to apply next. Kind of like we did on that one, was Connor was asking that one problem. If you're given a midpoint, what's one thing you always know is going to happen? You're going to get 2 congruent segments. That's probably what's going to happen next. Or if I give you supplementary angles, you know you're normally going to tell me they add up to 180, right? So use those things as cues in order to get there. Now, the very first theorem, notice I actually wrote everything in for you. Partly because I want to do the proof with you because it's way too fun, but also because I want you to see this one's a very common sense but a very visual proof that you can see. Common segments theorem says, given collinear points A, B, and C, and D arranged as shown, segment AB is congruent to segment CD if and only if AC is congruent to BD. If and only if means it can go as what? Both? All right, so notice that they're collinear. Guys, if these two segments are equal to each other, and I add one that's the same size onto both, the common what? Segment, wouldn't I create 2 new segments that are the exact same size? Right? Guys, I'm barely getting any registration that you're awake today, so come on, work with me a little bit more on this. If, let's try this again. If I know AB is congruent to CD, so let's just say that's both 3 and that's 3. The common segment is segment BC. Everyone with me? That's where they got the name from. If I add that segment onto both, shouldn't I get 2 bigger congruent segments? Yeah, they're both going to be length 8, right? So we know that AC would be equal BD. Can I go backwards? If I have the 2 bigger segments that are the same size. So let's just say instead I went, okay guys, look, these are both 8. If I subtract the same amount away, don't I get 2 smaller congruent segments? That's the common segment theorem. Now, let's actually prove it. Now, if it's a biconditional, you have to prove it both directions. Okay, so we're only going to go one direction. This time we're going to prove if you start with the smaller segments, you're going to get 2 congruent larger segments. Now, here's the diagram that we have. Our given is the fact AB is congruent to CD, so you should always mark up your given on your diagram and put it in your proof. So let's do this one real quick. Guys, first thing, first statement should be your what? Given. But knowing that, we're going to sit there and go ahead and say, okay, I know I'm going to have to do some math, because remember, even when I was showing you the visual up above, I said, if you add the common segment on, right? Well, we're going to have to do that. That means we're going to have equal signs. So the first thing I'm going to do is going to say, all right, I know by definition of congruent segments, I know that they're going to be equal in length. Now, look at the next step. Guys, what does that say there? BC is equal to BC. What property is that?
Reflexive.
Very good. It's a reflexive property. It's equal to itself. So we have our reflexive property. And we know that BC is equal to BC, its segment. But notice, what did I now do with steps 2 and 3? Did I add BC to both sides on number step 2 to get a new equation? So didn't I just do the addition property? Oh yeah, I just added it on. So I had my addition property. Now, let's go a little bit more. Look at the next one. I'm kind of stuck again. Or am I? Because here what I have, I got AB plus BC is equal to AC. Guys, AB plus BC is equal to AC. Had we had anything in our past that would help us with that? Yeah, some of the parts equal the whole, right, guys? Or segment addition postulate, right? So we know you can say that if you wanted to for number 5. Some of the parts equal whole. Those of you who like the name better, segment addition postulate for you, okay? I don't care which one of those you used. Now, the cool thing is, can I do that also for BC and CD? Are you guys with me on that? Okay. Notice now I'm using substitution property. This is where the algebra gets a little confusing. Do you guys agree with me that I substituted in segment AC for this spot right here. So notice I really combined, like putting AC in for AB plus BC down here. So I used substitution. It's icky, but it's what we did. I just substituted what I know. AC is equal to that, so I can put AC in for AB plus BC. Okay. So substitution property. You could have, but notice I did it again. So this is I'm really doing it twice. Remember, I'm showing it so you have no gaps, right? This is the part of proofs that no one likes. No gaps. So basically, I'm putting that in here. Now, can't I use the same idea? Can't I take BD and plug it in as well? It replaced BC plus CD, but I did the same thing. So guess what? Did I use the substitution property twice? Yeah, but that's okay. Now here's my thing. Oh, look, I have them equal in length. Well, if they're equal in length, are they congruent to each other? Yeah, so therefore I know by definition of congruent segments, they're equal to each other. Now, isn't that a lot of algebra to show that visually most of you caught when I just showed you with the little arrows, right? But that's what proofs do. Look at how much work you would have to do otherwise if we didn't have that proof. Want to do 7 steps in a proof anytime you wanted to apply it? No. We won't be able to know that. So memorize the common segment theorem. Now, I have another theorem for you. Will you please like firework this? Something that sits there and says, this is used till the end of time. Okay, I mean, it's one of those moments, okay? The vertical angles theorem is one of the most important theorems in geometry that you will see me use with you all year. It's kind of like definition of a midpoint. You use it all year. Vertical angles theorem all year. Okay, can I have a bone to pick with you guys a little bit about working with you on your quiz the other day? Most of you don't know how to spell vertical for the life of you, okay? Vertical is spelled V-E-R-T-I-C-A-L, not V-E-R-T-I-C-L-E. Verticil. Okay, we're not verticils, okay? What made me laugh is we were using it in the actual quiz, and the correct spelling was right above, and you guys spelled it wrong. Could we try not to do that? I mean, I understand spelling might not be your forte, and I'm sorry it's not automatically, corrects like on your Word documents. But if the word is right before you in it, could you please spell it correctly afterwards? Just good test taking skills. I just thought I'd let you know, but verticil is not a word. Vertical is. Got it? All right. Just making sure we're there. Some of you are laughing because you know you were the one who did that. So stop, okay? But just know, can we just at least try to spell it right? All right. Vertical angles theorem. Here's the easiest theorem in the world. It's huge. It saves us a lot of stuff here. If two angles are vertical, then they are congruent. Remember the definition of vertical angles say they're non-adjacent angles formed by the intersecting lines, correct? The vertical angle theorem says, guess what? If they're vertical to each other, I know I'm going to get angles that are congruent. And remember, how do we mark congruency? We use our arc marks, correct? Now, guys, think about this. The math behind this is wonderful. And in fact, we're going to prove it in a little bit. But the math makes sense. We know 1 and 4 are the non-adjacent ones. They have to be the vertical angles. But because of linear pairs, 1 and 2, 2 and 4, aren't those both linear pairs? If they're both supplementary to the same angle, aren't they congruent to each other? That's the congruent supplements theorem. So we're going to use the congruent supplements theorem. But you really will always get, when you have 2 lines intersect, how many pairs of vertical angles should you have? 2. And they're going to be what to each other? Congruent. And a lot of you saw that before. When we were doing some linear pair stuff, some of you wanted to play that earlier. All right, next one. Here's one that's so common sense. If, whoops, wanted to move on me here. If 2 supplementary angles are congruent, then each angle is a right angle. Now, guys, we all can see this real quickly, I'm pretty sure. Because if we know they're both equal, all right, that's pretty simple. We also know if they're supplementary, they add up to what, guys? Yeah, they add up to 180. Couldn't I just substitute one in for the other and literally show? So this is 2 times the measure of angle 2 equals 180. Can't you show that the angles add up are 90 degrees? So really algebraically, we know that has to happen. So if 2 supplementary angles are congruent, it's like, yeah, 180 divided by 2 gives me what? 90. And if they're a right angle, it's called a right angle, right? So if it's 90, it's right angle. How hard is that? But that's another theorem that we use that will help us out later. So should you know these? That's a vertical angles theorem. Do you think that should be memorized? Would that be a good one to put on like a flashcard or a Quizlet or something like that? All right, let's have fun. Let's prove the vertical angle theorem together. So you're given the fact you have a pair of vertical angles. I want to prove that they're congruent. So guys, let's go there real quick. Angle 1 and angle 3 are vertical angles. You always start with your given, all right? Now notice I have to go to my diagram now for any help. I have to go to my diagram now. Here we have angle 1 and angle 2 are a linear pair, and then we stated that angle 3 and angle 2 are a linear pair. All right, do you guys agree with that's true? Isn't that basically the definition of a linear pair? And what I would do is I'd also put diagram there, because where did I get that from? The diagram. Because when you're stuck, your diagram still can give you information. So from the diagram. Now guys, if they're a linear pair, you automatically know they're what? Supplementary. What theorem tells me that? Linear pair theorem, right? Do you see how we use our past theorems? If you have not been reviewing your past notes, you need to for proofs. Proofs are very hard if you don't. I had one person a couple years ago, you mean I could do proofs if I actually just reviewed my notes? And I was like, yes, I've only been saying that every day for the last 3 weeks, but yes, if you review your past notes, you've got everything you need to know. So guys, when I tell you to review your notes, review chapter 1 notes, all right? Review your chapter 2 notes that have this stuff. Now, remember, did I have any theorems that talked about supplementary angles and ones that maybe have congruency in them? This is where you didn't review your notes. Didn't I have a thing called congruent supplements theorem? What day? Friday. I didn't use something new, right? But if I have 2 angles that are supplementary to the same angle, they're what to each other? Congruent. That's just the congruent supplements theorem. And besides, didn't I just state that earlier in class? Right? All right, let's do some math. This is like the best stuff ever. I love these. Let's do some algebra before we do some more theorems. How's that sound? And this is algebra I expect you to know. All right, on the first one, you have to ask yourself, are those vertical angles? And everyone would say what? So what should you mark in your diagram? You should mark they're congruent, friends. You should always mark what you know in your diagram. If they're vertical angles, they're congruent to each other. So if I'm to solve this, doesn't that make your life really easy? I just sum equal and I solve for the variable. So then I get x is equal to, I got 30 here. So what you guys got? Good stuff. Now, does B look familiar from the other day? This came from our notes from Friday. And remember when we worked with this, you could have used this equation to solve for x or this equation to go for x. And then, who was in here that told me, Gregerson, can we try the vertical angles? Did anyone in here tell me that? There's someone whispered in one of my classes, like, vertical angles. And I'm like, not yet, But guys, we could set those up to solve for x, no problem. But could I also use the idea that these two are congruent because they're vertical angles? So now I do it one more time. I get 4x plus 1 is equal to 65. I get 4x is equal to 64. X is going to equal 16. If you look back in your 2-6 notes, guess what the answer was when I used linear pairs for this? X is equal to 16. So you have another way of doing it. Notice that's 3 different ways for solving for the same variable. 2 different linear pairs in a vertical angle. All right, how about the next one? Do I have a vertical angle in there? No or yes? What do you guys think? Yes. Do you guys agree with me? If that one's a right angle, doesn't this one have to be right angle because I'm using these two lines? So how would I solve for y then? Hallie? Yep, 4y plus 6y is equal to 90. Awesome. So I get 10y is equal to 90. Y is equal to 9. Beautiful. How about the next one, guys? Here's my question, are they a linear pair or vertical angles? What are they? They're vertical angles. So what do I know? I mark in my diagram they're what? Congruent. So I'm going to set them equal. So 6x plus 10x is equal to 33x minus 20. Oh no, Mrs. Gregerson, there's an x squared and an x. We don't panic. You're Geometry Advanced students. You sit there and go, oh, an x squared and an x. Possibility I'm going to have to do what? Factor. So you move everything to the same side of the equation if that's the case. You got 6x squared minus 23x plus 20 is equal to 0. Notice you always move it so the number in front of your x squared is positive when you're doing this. What's the first thing you should always look for? Do I have one? All right, so the next thing you work for is the signs. What are my signs that go inside my parentheses here? Yep, they're same sign, both negative. Excellent. Now, again, look at 6. I want factors of 6. What would be the two most natural factors of 6 you'd probably use? Yeah, 3x and 2x, right? Like, we're going to try those first. Great. Then I look at factors of 20. What would be possible factors of 20 that would be logical to use? 5 and 4, right? We try to pick the most possible. Can I put the 4 with the 2x? Because remember, that creates a what? Creates a common factor. If you put the 4 here, you already know you're doing it wrong. Because I can take a 2 out of that parentheses. So the 4 cannot go with the 2. Now what do we need to do to make sure we're right? I need to check it. I got to OI it, right? Outside, a negative 15x. Inside, a negative 8x. Guys, does that give me a negative 23x? We're so good. We got it right the first try. Once in a while, life goes well, right? So now what do you have to do? You set each equal to 0. My friends, those of you who do a lot of math in your head, this is where it seems to go wrong, that mess up errors. It's okay to show work. Now, here's the question. Are those both good answers? How would I know if they both work? Take your calculator and what? Check it back in. So all you have to do is go, like I would go 33 times 4/3 minus 20. See if it works. I go 33 times 5/2 minus 20. I'll tell you right now, the reason why I'm only doing that, the other ones I know will always work because you have a positive 6x squared plus 10x. So it's the negative that you have to worry about. And guess what? Both cases, they work. So do you think factoring can come up and get you guys a little bit? Yeah, and I expect you to know that. All right, one last proof. Anyone sitting there cursing proofs yet? Okay, stop it. They'll be your friends eventually, okay? Eventually. This one here. The thing when you're working with proofs is you should always mark your given in your proof if you can help it. So like right here, we're given the fact angle 1 and angle 4 are congruent. So this should have been marked congruent if they hadn't already done it. And I want to prove that these two angles, 2 and 3, I want to prove that they're supplementary. Now, that means this add up to 180. They don't have to be adjacent to each other. I just got to add them up to 180. Somehow I've got to prove that. Notice, am I making you do this proof on your own? No. But I do expect you to try some things on your own. So let's do the first one. Always start with your what, scholars? All right, so we got your given. Now, notice I have nothing else. So guess where I'm going to go to? I'm going to go to my diagram, and I'm going to use something I just learned. Did I have anything about vertical angles that could help me out? Yeah. Do you guys agree with me this is true, that angle 1 and angle 2 are congruent? Yeah, and that's the vertical angle theorem. And if you need to say from diagram so you know where you got the given, great. But the vertical angle theorem says that they're congruent. Now guys, look at steps 1 and 2. Can I combine them? What do you got? How can I combine them? Yeah, angle 2 is congruent to angle 4. That's the transitive property. Now, here's where most of us would get stuck, but this is why it's nice. They go, congruent angles have equal measure. So what I'm going to do with those two angles, I'm going to say they're equal in what? Measure. Basically, it says you're going to be doing some substitution later, I bet. Don't you guys think? All right, again, are we at the stuck level? Okay, we're stuck. But look what they pulled for us again. They told us the following. Angle 4 and angle 3 are a what? All right, so you guys agree with me. That's a definition of a linear pair. Where did I get that from, though? Didn't that come from the diagram? Because, again, our diagram's given to us, so we have fair game that we can pull it out. So we have a diagram with this one. So now, if I have a linear pair, they're what? Add up to 180. What theorem tells me that? Notice if I stayed their linear pair, I could automatically, the next step, use the linear pair theorem. Because once I know they're linear pair, the linear pair theorem's fair game. So this is my linear pair theorem. Notice we kind of cheat with the linear pair theorem. We either say it adds up to 180 or we say it's supplementary. Notice we just do which one works best for us, because are they the same thing? Kind of drives me nuts that there's not a clear fired way, but we know it works that way. Now, notice steps 4 and 6. Wouldn't it be nice to get rid of the 4? Look what happened. 4 and 6, I put it where? What property did I use? Yeah, I substituted in 2 for 4. I replaced it. So that was my substitution property. Now guys, here's my question for you. If two angles measures have the sum of 180, they must be what? Supplementary. So are we at our therefore statement then? Yeah, we're at our proof. Angle 2 and angle 3 are supplementary. And my reason is? Definition of what? Yep, definition of supplementary angles. Now, if you are a conditional statement type person, could you say the following? If two angle measures have a sum of 180, then they are supplementary. Would I totally accept that as a true valid reason? It's actually a very good way of writing it. I have a friend of mine that she would never let you write definition of supplementary angles. She would always make you write it as a conditional statement. To me, it doesn't really matter because you have to write it. All right? That was a little bit harder proof. But guys, are you starting to be able, even if we're working together, you're starting to at least follow, like, you have to use the previous steps to get the next steps. If you're stuck, you either go to given or the diagram to get something, right? You guys with me on that? Okay, so guess what you have for homework? Proofs. Isn't that just so cool? I will have a lot more time tomorrow to go over them with you, though. If you guys are good with that, all right? So a little more time. Let's see. How many of you have started on your review for the test? The rest of you, guess what? You're going to want to. It's long, really long. You can just pull it up and you can just work on it on OneNote. Or you can put it in Dropbox. Yep. Yes, ma'am.
What is the homework
supplement? The homework supplement, remember when I will give you extra worksheet to go with it? It's some 3 proofs that you have to have. It's online. So do your book work and then insert the worksheet and then do your book work below it. So you have to pull it up online. Did everyone hear? This is a good question. Homework supplement for this lesson. It's in the homework assignment. It's just a worksheet that's additional to the book work. Are you guys with me? Everyone shake your head. It's proofs. You need to do it. All right?